Good afternoon, everybody. And today I am going to complete the harmonic oscillator part. It is continued from the previous class. So in the last class we have discussed about the partition function for one-dimensional harmonic oscillator, which is later extended for three-dimensional system or two-dimensional system. Okay. And another thing is that in exam, what happened I am strictly following the Pathria book. You can check it in page number 68, 69, 67 page. It is already given. Okay, but in the books, what are the difference between my class and the book? In book, what happened? They have written the equation. After that, they will final result written write down. Okay, from where they derive and how they derive, this all detailed information not provided in a book. Okay, that's are left for us. And another important thing is that in books they have derived the equation for example harmonic oscillator. This for one dimensional, but two dimensional case, three dimensional case they have not discussed. So in exam what happen, often ask this type of question. So in books one dimensional given it, but in exam it is asked normally two dimensional. So student get confused. So in order to avoid confusion, I have given all clear-cut answer, how you have to approach, what are the correct answer, how you have to understand the question, that I have given. Okay. Now this is a classical harmonic oscillator. Okay, classical harmonic oscillator. So partition function I have already calculated. Partition function for one-dimensional and harmonic oscillator, Kt is cos omega to the power n. Okay, if n harmonic oscillator indistinguishable, then 1 by n factor will not be there. And in exam what happen, you will be given the partition function. Okay, and after that they will ask you who is find out the entropy or find out the free energy. Okay. So I have calculated the free energy first. Free energy I have calculated. This is the free energy formula, minus Kt ln z. Okay, I am writing again. So it will be, if you put this value, you will get a value n Kt ln is cos omega by Kt. Okay. Now one thing is always remember, the energy in classical, mean energy of classical oscillator is mean energy is Kt. Mean energy of classical oscillator. Okay. And for n one-dimensional harmonic oscillator, mean energy we often write E also, E or U, whatever it is. It always remember it is the mean energy of n one-dimensional harmonic oscillator n Kt. Okay. And this mean energy is satisfied the equipartition theory. Always remember, the mean energy calculated from this equation is also satisfied with the equipartition theory. Okay, or from equipartition theory you can verify the Hamiltonian of a one-dimensional harmonic oscillator. We write like this. So twice n plus half kx square, right? So what are the harmonic term? Always remember, whatever Hamiltonian, suppose I am writing alpha x. Okay, what are the harmonic term? How many degree of freedom? 1 or 2. Okay, we never count this one. Okay, and another important consequence, harmonic term means square term contribute the energy. This is odd term, it will not contribute the energy. Because why? Because we are going to calculate the mean energy. Mean energy is like that. In statistics, continuous system, it is 0 to minus infinity to infinity. E to the power d e to the power minus beta e z. So what happens if it is odd function? It will 0. So odd term never contributed. Okay, always remember. And only this term, according to equipartition theory, energy associated with its degree of freedom is half Kt. This is half Kt, mean energy of this part, and this will half Kt. This will 0. This will not contribute Kt. Is it matched with this one? This calculation is obtained from this type of calculation, and this is mean energy for single oscillator, and this is from equipartition theory. It is matched. So classical equipartition theory hold good for one-dimensional harmonic oscillator in classical system. Okay, this is matched. For n particle there will be n. Clear? So in that case, why I am writing here, in this case you have to E equal to NKT, KT equal to E by N, KT equal to E by N, then NKT ln is cos omega N, then the E, NKT equal to E ln is cos omega N E. Okay, this, remember this formula. Why I am giving in terms of this, up to this part in the question in books already given. Okay, I am giving you up to this part. Why? Because in I have seen the question paper, they will written like this: if the partition function of a single one-dimensional harmonic oscillator KT by E cos omega to the power n for whole system, then which of the following is the correct representation of free energy? Their answer is given in terms of E. So if you do calculation up to the, you may confuse. So never confuse with this. You just replace E, this one, you will get the final result. Okay. And in exam, you will not be asked to solve all the problem. Either they have given the partition function, you have to find out the free energy, or either they will give a free energy, you have to find out the entropy. Okay. Then and another important consequence, how to analyze special case. In one question I have given you, the question is given that the free energy partition function of a system is KT is cos omega to the power n. Okay, partition function of the system is given by one dimensional, n number of particles is given by them. Okay, under which condition free energy of the system becomes 0? The condition was, one condition, the answer is given is cos omega greater than KT, and 2 is cos omega less than KT, 3 and A is cos omega equal to KT, 4 none of above. Which one is correct? So you see this question, this is a band gap of energy in the Schrodinger oscillator I have shown you, and this is the classical and average energy of oscillator. So if this is equal, then ln1 will become 0. So this condition is correct. This is how you have to understand. Okay. You try to extract the information from the equation itself, because equation itself gives a lot of information. You no need to spend your valuable time reading all linguistic information given in a book. Okay, whatever information you can extract from the equation, you try to extract that only. That's enough for you. Okay. Next, if I calculate the next I am going to calculate the chemical potential. Chemical potential. What is the chemical potential? Represented by mu. So suppose you don't know the formula of chemical potential. So how can you remember suppose you don't know anything. So how can you remember the chemical potential? You always remember one thing I am telling you again. If you want to find out pressure, volume, entropy, temperature, chemical potential, any one of these variables, magnetization, any one of these variables, if you want, this is at a thermodynamical parameter. Okay, pressure, volume, temperature, entropy, chemical potential, magnetization, whatever it is, mean energy, free energy. Okay, if we want to calculate any one of these variables, always remember these two equations. dq, this is a thermodynamical, dq equal to du plus dv. Du means you can replace d. Okay, do not confuse. This equation 1 you remember. Second equation, a equal to u minus ts plus mu n. This equation is free energy calculation, or this term may not be, this term sometimes we never write. Why? Normally we write a equal to u minus ts, but in canonical system plus mu n you have to write. Okay. If only you have to remember these two equations. If you can remember this equation, you can calculate pressure, volume, entropy, temperature, chemical potential, magnetization, free energy. All terms you can calculate. Okay. That is why you focus on only remember in exam this equation. Now suppose I don't know I forgot the formula of chemical potential. So you remember this formula: A equal to u minus ts plus mu n. Okay. Again I am telling you. Yeah, I have already given you. Again I am telling you how I can apply this formula as an honeycomb. Okay. You do the differentiation. du means d, same thing. Okay. Mean energy. du tds. I take the differentiation both sides. Minus s dt minus mu dn. So this is not two variable. Okay. Mu is constant. That's why I am not going to n. D mu is always 0. Okay. Then I remember the formula dq equal to du plus pdv, right? So dq means tds. Tds equal to du plus pdv. You replace the tds or du. Du equal to tds minus pdv minus tds minus sdt plus mu dn. Okay. TDS cancel, equal to minus PdV minus SDT plus mu dn. Oh, correct. Okay, now I calculate, suppose I need chemical potential. So this term I need. So if volume is constant, temperature is constant, then D equal to how much? dA equal to mu dn. Okay, when volume, temperature constant. If these two parameters constant, this term 0, this term 0, so I can simply write mu chemical potential equal to dA by dN. Okay, volume and temperature constant. Okay, easy, no need to remember. So I will write mu equal to dA by dt volume and temperature constant. So okay. Volume and temperature constant. What is the free energy? I have already given you free energy equal to how much? nkt. Okay. ln what? H cos omega by kt. Is it okay? So only take the differentiation. What is the value? T is constant. T constant. This is dn. Okay. T constant. First term will be what? T constant and kt ln h cos omega kt, right? First term only with respect to n. All other constant, only one term. So this is the free chemical potential. So chemical potential is also 0 when band gap of energy level of Schrodinger harmonic oscillator equal to the classical oscillator mean energy of classical oscillator. If it is equal, this is the band gap. So I can represent like this: kT ln del E by kT. Okay. Or I can replace k. T is there. Okay. T kT ln del E by n. Right. So k T ln E n by E. This is chemical potential. Okay, chemical potential is equal to 0. At T equal to 0, what happens? T equal to 0, chemical potential becomes 0 also. Oh, is it okay? Suppose if somebody at T equal to 0, what is the chemical potential of harmonic oscillator? It's 0 because T is there. So 0. At T equal to 0, chemical potential 0. Okay, and another condition, when band gap of harmonic oscillator equal to a mean energy of classical oscillator, then is okay. The chemical potential also 0. These are the consequences you can extract from the equation itself. Okay. Another is second, third, fourth term we are going to entropy. Entropy S. What is the formula of S? I have already given you. dA equal to, what is this? Minus SDT minus PDT, okay, plus mu n dn. Is it okay? Is it okay? I have already derived in the previous equation. What is the value of S? Minus dA by dt when V and N constant. Clear? So S equal to dA by dt V and N constant. So what is the value of free energy? So in exam what happen, they will give the free energy, you have to find out the entropy, or sometimes they will give a entropy or free entropy, you have to find out the free energy, reverse order. So both you can do. So already I have told you free energy and NKT ln is cos omega kT. This is the free energy of a system. So what is the entropy? Minus V constant and constant. So forget about that. You have to find out differentiation, which is first term is nk ln is cos omega kT. Okay. Second term will be what? Second term will be n kT logarithm a is cos omega by kT, right? 1 by x, logarithm differentiation of log x. Then it will be a is cos omega by k, then d by dt 1 by t, right? This is the calculation you have to do. Okay, this whole part cancel, t never cancel, is there, minus nk ln is cos omega kT plus nk, okay, nk is t square, it will give what? Minus of 1 by t square, right? Minus of t square, so it will be nk ln is cos omega kT, this will plus t cancel nk equal to, this is minus nk comma ln kT is cos omega plus 1. Is it okay? So finally what we are getting here, you can write nk ln kT is cos omega plus 1. We are getting this value. Okay. So in books they have directly put this value directly. In book you can check in page number 67 page number. Okay. Now if I replace classical energy equal to how much? KT equal to E by N. So E by N is cos omega plus 1. See, now in 2000 net paper, 2007 net paper to 17 or 14 to 17 net question paper. Okay, what they have given? If the entropy of a harmonic oscillator is given by this one, correct? Then find the temperature of the system. Can you calculate the temperature of the system? So what are the formula you have to replace? So you remember this formula, dA equal to, so you see, how can you remember dA equal to minus S dt minus P dV plus mu dN. So I need to find out temperature. Here temperature is not there, and using this formula you can calculate entropy, pressure, chemical potential. Okay, temperature you cannot do. So another formula you have to focus on. Only two formula you have to always remember. One formula this one, another formula is this one. dq equal to du plus P dV. dq means TdS. du means never confuse. This is the mean energy. dE replace dE plus P dV. So T equal to what? T equal to dE by ds, correct? When volume is constant, correct? So in net question paper they have given, if this is the entropy of the system, what is the temperature? So temperature you can calculate. How can you calculate? Temperature equal to dE by ds, correct? But you can, because S is given, I can replace 1. I can do one thing, ds by dE. Is it okay? Because S is given, so E is not given. So that is why I reverse the differentiation. So now you can do the differentiation with respect to E. So what will be the value? ds by d equal to, this is constant, this is constant, this is Doppler, nk ln e by n h cos omega. Okay, then e is e by h cos omega. One by n h cos omega. So n h cos omega and h cos omega cancel. Nk is it okay? N h cos omega and h cos omega cancel, and e will be there, nke. Okay, then what is the value? 1 by nke. Nk by E, sorry, E by Nk. This is the temperature of the system. This question comes in the NET exam. Okay, this question comes in the NET exam. This is very easy. Entropy of a harmonic oscillator is given by this one, or you can express kT is replaced by E. Now find the temperature. Temperature is from thermodynamical relation. Temperature equal dE by ds, or reverse. You can take inverse of ds by dE. Why? Because S is given. That's why S is keep in the numerator part. We differentiate in order to differentiate with respect to E. We differentiate this part, and whatever value we put this value, that is entropy. This is a 5-mark question. Okay. Then next, I'm going to calculate the mean energy. Okay, mean energy I have to calculate mean energy. Mean energy. How can you calculate mean energy? So only two formula you have to remember. A equal to U minus Ts. This formula. Okay. Current is not available. Whether it is visible, I don't know. I think it is visible. So U minus Ts is just, I am not writing the U and term because it's not necessary every time. So mean energy mu is equal to A plus Ts. Free energy I have already derived. So free energy is equal to NKT, free energy. Okay. KT ln h cos omega by KT, right? Free energy. This is free energy. Plus temperature into entropy. I have already taken out entropy equal to, and T is already there. Entropy is equal to how much I get it? NK ln KT by h cos omega plus 1. I am getting this one. Is it okay? So this will cancel because this NKT T ln h cos omega KT plus this will be minus. Why it is minus? NKT T ln, I take it reverse because it is reverse, h cos omega by KT plus NKT. Okay. Finally we are getting NKT. Correct. This is the mean energy of a harmonic oscillator using this formula. Or you can calculate from mean energy from the equipartition theory. Again I am telling equipartition theory. This is the P square by twice Px, one dimensional, half Kx square. This is for only one harmonic oscillator. So mean energy equal to how much? Mean energy equal to how much? Half KT plus half KT equal to KT for one oscillator. For n oscillator mean energy, for n oscillator how much? N KT. You see, mean energy calculation is satisfy the equipartition theory. That means classical oscillator satisfy the equipartition theory. Clear? So any other term? Another equation, if you want to calculate mean energy, because from the entropy calculation of it. So mean energy, you can calculate mean energy A plus ST equal to A minus T. This formula you can calculate free energy. Suppose why I am writing here, suppose entropy is not given. So free energy in question paper, they suppose they have given that if free energy of a harmonic oscillator is this one, what is the mean energy? Then you have to use this formula. Otherwise what happen, you have to find out free energy, then entropy, then you have to mean energy. So what I am doing here, instead of going to calculate entropy, you just put the entropy in terms of free energy. Then you calculate. Then one term no need to calculate. Then free energy I have already calculated. If you calculate this one, you will again get NKT. Okay. NKT is the mean energy of a classical one-dimensional oscillator of N system. Remember. Suppose I am again telling you, this is suppose one-dimensional N. This is suppose 1D N number of harmonic oscillator. Then mean energy you are getting this one, NKT. Okay. Suppose if I take a consider system of n atoms, n particle, three-dimensional particle, then you will get the mean energy thrice NKT. Remember. And passivity in this calculation du by dt, so it will be 3nk equal to thrice in 3 dimension. Now it is 1 dimensional. This is a classical theory, so it is satisfied Coulomb and Petit law. So passivity equal to how much? Du by dt and nk means r. It is 1 dimension. If it is 2 dimension, then it will be, you will get 2r. If it is 3 dimension, then you will get 3. Okay. This question I have already discussed. And another question comes in the exam. Which oscillator? Now you can, I think you can answer the question. Which oscillator has energy inverse of temperature? The question is that answer is classical oscillator. Option is that classical oscillator and Schrodinger oscillator and Planck oscillator. Which one is correct? So which oscillator has energy is inverse of temperature? Which energy? This question comes in exam. Classical oscillator energy, I have classical energy mean energy this one. This energy means 1 by beta. Is it okay? Inverse of temperature. Beta equal to 1 by kT. Inverse of beta. So Schrodinger oscillator this one, n plus half is cos omega. No need. There is no question of temperature. And Planck oscillator is cos omega. Okay. And another important question, when 0 point energy of the system is not considered, then Schrodinger oscillator become Planck oscillator. That means this part half is removed, then n is cos omega is this one. Here 0 point energy is considered, here 0 point energy is not considered. Okay. Now we are going to quantum oscillator. This is a classical oscillator. What about this question? This is a very important part for NET exam, GATE exam, that is given in around 66 page, 67 page, 68 page in Pathria book, section number 3.2 and chapter number 3 Pathria book. Okay, calculation is not given, answer is given. So whatever I am giving here, you just do it and you try to understand. You can easily understand the Pathria book. It's very easy. Only difference that they are not going to, they have not calculated the partition function for 2D, 3D like that. They have given the partition function of one dimensional harmonic oscillator. That's all. After that 2D, 3D you have to calculate. Okay, now I am going to quantum oscillator. Quantum oscillator. 3D quantum oscillator. Okay. Now when I consider the 3D oscillator, important point. See. Energy, normally we write the energy of a oscillator. Energy of oscillator En equal to n plus half is cos omega. It is always, remember, this is one dimensional potential energy. One dimensional energy of a harmonic oscillator. Okay? Do not confuse. This is one dimensional energy of harmonic oscillator. Suppose in case of three dimensional case, I am giving him this three-dimensional case. it is only one dimensional. I am giving a idea of quantum mechanics. So otherwise you may confuse. Suppose harmonic oscillator potential is equal to half kx square plus y square plus z square, or you can write k equal to half m omega x square k is equal to omega square equal to k by m. See, okay, x square, then the half m omega y square plus half m omega z square. This is the oscillator. Okay, this is a three-dimensional potential. Okay, now what happened? I consider this is Vx, this is Vy, Vz. Okay, this is Vx plus Vy plus Vz. So that means what? If I suppose Vx not equal to Vy, not equal to Vz, this means potential energy along x-axis is not similar with y-axis, not similar with z-axis. That means this oscillator, three-dimensional oscillator, is anisotropic behavior. Have anisotropic behavior. Anisotropic behavior means any property along x-axis not similar with y-axis, not similar with z-axis. That called it is anisotropic harmonic oscillator, three-dimensional harmonic oscillator. So energy in this case will be nx half is cos omega x. Okay, this is one thing. This is for this, and there is a total energy will be potential energy and kinetic energy. Okay, kinetic energy is remain fixed, px square by twice m plus this one, py square by twice m plus this one, pz square by twice m. So total energy of this one, ny half a omega y a square plus nz plus half omega z a square. This is the energy of a harmonic three-dimensional anisotropic harmonic oscillator. Okay, this is the energy three-dimensional of harmonic oscillator. Anisotropic. Case 1, anisotropic harmonic oscillator. 3D harmonic oscillator. Now second case, if it is isotopic. Case 2, isotopic case, what happened? Then omega x equal to omega y equal to omega z. That means Vx equal to Vy equal to Vz. All is symmetric. Potential along x-axis, y-axis, z-axis symmetric. So energy will be how much? Nx plus ny, combining all this. So I will write one term more so that you understand. En equal to nx plus half omega is common, equal to omega, so a cos plus ny plus half omega is cos plus nz plus 1 by 2 a cos omega. So omega is common, so I can write nx plus ny plus nz plus 3 by 2. Okay, a cos omega. This equal to, normally we represent this is n half 3 by 2 is cos omega. Remember, this is the energy of harmonic or three-dimensional harmonic oscillator, isotopic medium. Okay. So one question I have written here so that you understand. And this you can study this part. You will study in quantum mechanics and the three-dimensional system in quantum. I think chapter number 6 in Jatili books. Three-dimensional system, three-dimensional particle in 3D box, particle in harmonic oscillator, particle in hydrogen atoms. The three-dimensional system, you will get this formula, and you can see degeneracy also exists in symmetrical problem. Degeneracy in previous example, anisotropic harmonic oscillator. That means frequency is not same along XYZ. That case there is no degeneracy. Okay. And now you probably, I know you know what do you mean by this. Degeneracy means having different state but common energy. Okay, suppose I can stay in Jorhat, I can stay in Guwahati, I can stay in Tezpur. but that means 3 different orientation is there. That means 3 different wave function associated with me, but I am the same person. Energy associated with the me is same, that's why unequal. Same person is located in different location. That means in quantum mechanical world, a wave function have different orientation or different possible state, but have commonality. That is known as the degeneracy. So degeneracy, in this is the 3-dimensional case. You will find in the quantum mechanics also. I am giving hints. Degeneracy equal to half n plus 1 into n plus 2. Okay, this is in 3-dimensional case. But in 1-dimensional case, there will be no degeneration. Degeneration exists only multi-dimensional, or 2-dimensional or 3-dimensional, and only symmetrical problem. If it is Vx is not equal to Vy, not equal to Vz, then there will not be degeneration. So 2 requirements. One is it must be more than 1 dimension. Second, it must be symmetric, dimension symmetric. Okay. Suppose in 2-dimensional case, the same problem if I write in 2-dimensional case. Suppose in 2-dimensional case, in 2D isotopic harmonic oscillator, energy, how can I, isotopic means V equal to half m omega square x square plus y square. That means omega x equal to omega y equal to omega. This isotopic. Okay, but it is 2-dimensional. So energy will be what? And 2-dimensional energy n x plus ny plus 1 is equal to this will be the value. So normally it is represented by n plus half is equal to. Okay, this is in case of 2-dimensional harmonic oscillator. Never confuse. It is 2-dimensional isotopic harmonic oscillator energy. Okay. And degeneracy, this in 2-dimensional n plus 1. In quantum mechanics also, in quantum mechanics Jatili book, they have explained the degeneracy for 3-dimensional very well. But they have not written the harmonic oscillator in 2-dimensional and their degeneracy. Your degeneracy in 2-dimensional n plus 1, this question comes in the exam. Okay, remember, what is the degeneracy of 2-dimensional system? This is a half n plus 1 into n plus 2, that is a degeneracy of harmonic oscillator in 3-dimensional, this is 2-dimensional. And 1-dimensional degeneracy not exists. Degeneracy does not exist means degeneracy equal to 1. Okay. This is 2-dimensional harmonic oscillator. Okay. This is a basic, that's why I am going to tell you. One question you can understand. This question comes in the near exam, 3-mark question. So harmonic oscillator has potential. Harmonic oscillator, a question, remember, a harmonic oscillator has potential energy Vxy z equal to half m omega square x square plus twice m omega square y square plus 8 m omega square z square. It is 3-dimensional. How can you know x, y, z? It is 3-dimensional case. Now in original formula, half m omega square, half m omega y square, half m omega z square is there. So I have to reduce this equation in that form. It is very easy. The question is that if the potential of a 3-dimensional harmonic oscillator is this one, what is the exact energy of the harmonic oscillator? So I have to first of all, what value I have to find out? Omega, frequency I have to find out. So this is omega x, this is omega y, this is omega z. So I will try to make this equation in standard form. Okay, m omega square, it is already in standard form. Okay, first term. Second term I can write half m twice omega square. Is it okay? 4, it is 2. Now it is standard form. Y square. Okay. Now I can write half m 4 omega square z square. Is it standard form? Half m omega square, half m omega. This is omega. Twice omega means omega y. 4 omega means omega z. Omega x square, omega y square, omega. Now it is standard form. So energy omega equal to omega x equal to omega, right? And omega y equal to twice omega, right? Omega z equal to 4 omega. Now nothing to do. Just you remember the formula. Nx plus half omega x is equals. Okay, what you can understand, this is an isotopic harmonic oscillator. Why? Because omega is not equal to omega y, not equal to omega. This is an isotopic harmonic oscillator. Okay, so it will be ny plus half omega y is cos plus nz half omega is omega z is cos. Now put this value, you will get the value. Now put the value, nothing to do. The answer is, this question is 3 marks. Now put the value, E equal to nx plus half omega is cos, next ny plus half twice omega is cos plus nz half 4 omega is cos. Now calculating. This is the answer. This is 3 mark question. But why I am giving in statistics, because I have taken some part of quantum mechanics to statistical, some part of condensed matter physics to statistics, and electronics to the statistics, and atomic physics also statistics. Then what happens if you study one chapter, this chapter clearly, most of the physics you can easily understand. Okay. This is a quantum mechanics, isotopic harmonics. Clear? This is how you have to find out the answer. Now I am going to the calculation of partition function of quantum harmonic oscillator. Now you see, I have calculated partition function for classical oscillator. Now I have to calculate quantum mechanical oscillator. Now you may ask question, why I have not used the partition function this continuous form. You see. So now I am going to calculate partition function or mean energy. Now you may ask question, why I am not considering the partition function in continuous form. Can you tell me? Can you tell me why? I am going to write this equation, sum of n equal to 0 to infinity e to the power beta en. This formula I am going to use. Why I am not going to use integration formula? Because in quantum mechanics, the energy exchange takes place not in continuous pattern. It is a discrete pattern. H nu, then twice H nu, 0 H nu, twice H nu, thrice H nu, 4 H nu, like that. So already black body radiation I have already told you. So it's a discrete pattern. That is why I am using summation. Okay. And this equal to, I have already given you trace of exponential matrix beta E. Okay. This is in partition function. There is a 3 partition. One is integration form, one is a discrete form, one is a matrix form. Okay. I had that day I have told you, if suppose A is a matrix 3 by 3, A1 0 0 0 A2 0 0 0 A3. Suppose A is a Hermitian matrix, it is a 3 square matrix. Okay. And the non-diagonal element of any square matrix is 0, means all diagonal element represent the what? Eigenvalue of the matrix. So there is a 3 eigenvalue 1, 2, 3. So lambda 1 equal to A1, lambda 2 equal to A2, lambda 3 equal to A3. So, okay, if I want to form an exponential matrix, then what happen? Nothing to do, just e to the power A1 0 0 0 e to the power A2 0 0 0 e to the power A3. Clear? So similarly, trace of matrix equal to what? The sum of diagonal element. So sum of trace of equal to this e to the power A matrix means what? It is sum of e to the power AR, right? So similarly, trace of this is exponential matrix. This is exponential. Sum of trace means you can, this matrix you can expand like that. So this matrix you can e to the power E minus beta E1 0 0 e to the power and dot dot dot. I am giving an example. That's why I am writing only two from. Okay, there will be n dimension. So it will be what? Sum of trace means what? Sum of diagonal element equal to e to the power minus beta E1 e to the power minus beta E2. It is what? Z partition function. So that is why I am writing trace of exponential matrix, right? So I will discuss in this matrix representation of partition function is very important in quantum mechanical field, because most of the problem is asked in the exam, in net exam. So they will ask energy in perturbation Zeeman effect. In terms of they give you Pauli matrix. Pauli matrix is a matrix form. Then you have to convert the equation, energy equation in matrix form. Then you have to find out the partition function in matrix form. Then you can find out the value. So now this is a, remember quantum Schrodinger oscillator I am using. Schrodinger oscillator. Why Schrodinger? This I am going to use this use this formula. This is the energy of 1D harmonic oscillator. Harmonic of quantum mechanical. Previous one is a classical. This is one-dimensional harmonic oscillator energy, quantum harmonic oscillator energy, which is calculated using Schrödinger equation, and that is why it is known as a Schrödinger oscillator. Clear? So, if I put this value, now I will put this value, then what I will get? E to the power minus beta is cos omega by 2, first term, right? Second time, e to the power minus n is cos omega beta, right? This is a constant, n equal to 0 to infinity. E to the power minus beta is cos omega by 2. So e to the power minus is cos omega beta to the power n. Is it okay? Is it okay? Now it is a constant. First term is a this equal to, I can put equal to constant, equal to e to the power minus beta is cos omega to the power 2 sum of x to the power n. Yes, this part equal to xi constant. N equal to 0 to 1, 0 to infinity. So what I am getting, z equal to e to the power minus beta is cos omega by 2. Now x sum of n equal to 0 to infinity x to the power n, right? E to the power minus beta is cos omega by 2, right? It is first term is 1x plus x square plus x cube dot 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 dot. Is it okay? And in SS you have studied this type of formula, 1 minus x minus 1, 1 minus x minus 2, 1 minus x minus 3, 1 minus x to the power minus n. Binomial theory, have you remember this? This is what? Binomial theory. E to the power minus beta is cos omega by 2, and it will be 1 minus x to the power minus 1. Clear? So you will get e to the power minus beta is cos omega by 2, and 1 minus e to the power minus beta is cos omega. Clear? So what I am getting here, in case of Schrödinger oscillator, this is one dimensional, okay? One dimensional partition function. I am getting here partition function equal to, and e to the power minus beta is cos omega by 2, 1 minus e to the power minus beta is cos omega by 2. And this question comes in the NET exam. You can check in a question paper, NET question paper, that which of the following is a correct representation of partition function. Okay, this is a very easy calculation. It hardly take 10 seconds or 15 seconds, not beyond that. Okay, now if I take this, I can convert this from 1 e to the power beta is cos omega by 2, right, minus e to the power beta is cos omega by 2. Is it okay? So it is a sine hyperbolic function. It is a sine hyperbolic function. 2 sine hyperbolic beta is cos omega by 2. Is it okay? Clear? Now question is there. Now you have to understand. Now you probably understand. This is a partition function of quantum mechanical oscillator, one dimension. Okay. Suppose if I give you the energy in question, I have seen the question paper in there. Okay. They have given energy equal to nx square half h cos omega plus ny plus half h cos omega y. This is x. If it is harmonic oscillator, energy of two-dimensional harmonic oscillator, quantum means this is a Schrödinger harmonic oscillator, is given by this. What will be the partition function? So partition function, it will be product. Why product? If you put this value in partition function formula, you will get a two separate summation. So partition function will be same, equal to z1 into z2. You can check it also. I am not going to check because of time constraint. Okay, you will get the partition function into the power omega is into the power beta is cos omega x. Okay, 1 minus e to the power minus beta is cos omega x. Next, e to the power minus beta is cos omega. This is a 2. Sorry, 2 is cos omega y by 2, and e to the power minus 1 minus e to the power minus beta is cos omega y. Is it clear? It is 2-dimensional. 3-dimensional, then one term will be added. But it is omega x. That in the question they have not mentioned whether it is isotopic and isotopic. Suppose in isotopic case omega x is equal to omega y, then both term will be equal. Then both term this is only omega x not equal to omega y. Okay, that means what? It is anisotopic case. Anisotopic 2-dimensional harmonic oscillator. But in case of isotopic harmonic oscillator. So in case of isotopic harmonic oscillator, e to the power minus beta omega is caused by 2, 1 minus beta is cos omega, sorry, is cos into e to the power minus beta is cos omega by 2, 1 minus e to the power minus beta is cos omega by 2. You can write as a e to the power minus beta is cos omega by 2, 1 minus e to the minus beta is cos omega by 2 is not there, okay? It is mistake. 2 square. Is it okay? Suppose if it is 3-dimensional, then if it is suppose this one nz plus half is cos omega z, then what happen? 3 term will be added. Then another term will come here. Then in this case partition function will be this one. Partition function will be e to the power minus beta is cos omega x, okay, 1 minus e to the power minus beta is cos omega x, 2 into e to the power minus beta is cos omega y by 2, 1 minus e to the power minus beta is cos omega y, this is y, into e to the power minus beta is cos omega z, 1 minus e to the power minus beta is cos omega z. It will be like this. Isotopic, if it is isotopic, then it will be e to the power minus beta is cos omega x, omega or omega x equal to omega y. Then it will be 1 minus e to the power minus beta is cos omega by 2 q in case of isotopic cases. Okay. So my mobile battery is down, that's why I'm not going to do that. And you can convert it 1 by 2 sine hyperbolic beta is cos omega by 2 to the power t. Okay. So if this n atoms, if there is a n atom, suppose if there is a n atom is there, so total harmonic oscillator will be how much? This is 1 by 2 sine hyperbolic beta is cos omega by 2 to the power 11. And special case I will discuss it later. Okay. Then I will go into the discuss. So I'm going to discuss special case. So again back to the partition function of single harmonic oscillator, I finally get 2 sine hyperbolic beta is cos omega by 2, right? So now can you tell me what is the formula of e to the power sine hyperbolic x? What is the formula? Sine hyperbolic x equal to x plus x cube by 3 factorial plus x5 by factorial 5 like this, and cos hyperbolic x equal to 1 plus x square by factorial 2 plus only even term 4 like that. Okay, now you see this equation I can expand to beta is cos omega by 2 plus beta is cos omega by 2 1 by 3 factorial 3 like that. Okay, I can expand 1 by 2 is cos by kt 2 kt plus is cos by 2 kt cube 1 by factorial 3, right? factorial. I can expand. Now you check it. When temperature is very high, when temperature is very high means this term is very small. This is equal to how much? Case study you have to do. So case one. When in exam you have to, they will ask in a case study when beta tends to very greater than t or very less than t or tends to 0, something like that. So first condition, when beta is very greater than a cos omega or beta tends to infinity. So what happened? Beta tends to infinity means what? Beta equal to 1 by kt. Beta tends to infinity means 1 by kt. T tends to 0. Okay? Or t tends to 0. Same meaning. These two has same meaning. So what is the value of this one? What is the value? T tends to 0. Energy becomes, it will become what? Reverse. It will become, or you can check it from here. Z equal to, I can write simplified way, e to the power minus beta is cos omega by 2, 1 minus e to the power beta is cos omega. This is the formula. So beta means infinity, e to the power minus infinity. Okay, 1 minus e to the power minus infinity equal to how much? E to the power minus infinity equal to how much? E to the power minus infinity means 0. 1 minus 0 equal to 0. Is it okay? Similarly, you can take it from here also. Z equal to, I have using this formula, same formula. This is one formula. I can similarly beta is cos omega by 2 minus e to the minus beta is cos omega by 2 equal to 1 minus e to the power infinity, e to the power infinity minus e to the power minus infinity equal to 1 by e to the power. It is 0. E to the power infinity means what? 1 by infinity plus infinity square by factorial. Do like that equal to 0. So that means what? From this equation you can verify, this equation you can verify, any equation you can verify. Okay. What you can understand? When temperature is 0, number of possible microsteps becomes 0. That means what? In quantum mechanical oscillator, number of possible microsteps means possible step. Okay, 0. There is no possible state. At t equal to 0, all states there is no possible microstate. Microstate becomes 0. This is the meaning of this equation. Z means my number of microsteps. Again, when temperature is infinity, now my condition is what? When beta tends to 0. Beta tends to 0 means t tends to infinity. Same meaning. Okay. Then what happened? Can you just, you can do at very high temperature, you can do the calculation according to this. Okay, I am not going to do that. So this condition you can easily find out whatever I have given, because I am not going to give you all the case study, because I am giving you hints how to do the case study because of time limitation. Okay. Otherwise I cannot cover all the topic. And what happened at t equal to infinity, you see z equal to how much? 1 by e to the power beta is cos omega by t minus e to the power minus beta is cos by e. I can take this formula. Okay. Or you can take this formula, z equal to 1 by 2 sine hyperbolic beta e. Beta is cos omega. This is the formula I have already taken out. Beta 2. So you can expand 1 by 2 sine hyperbolic function. So first term will be beta is cos omega by 2. Second term will be 1 by 3 factorial beta is cos omega by 2 cube, like that. So if the temperature is very high, so I will not consider this whole term. So it will be what happened? I can take only first term. The temperature is very high. The temperature means denominator. Beta equal to 1 by kt. So I will only consider 2 into beta is cos omega by 2. Beta is cos omega means 2 kt. So 2 to cancel equal to kt by is cos omega. From this equation, similarly from here, if you do here calculation, you will get 1 plus beta is cos omega by 2 minus 1 minus beta h cos omega by 2. So exponential series. Only first and second time I am consider E equal to kt by h cos omega. So what do you understand? Now what do you understand? At very high temperature, this is the energy of what? Classical oscillator. Already I have in previous class. So at high temperature, the quantum mechanical oscillator behave as a classical oscillator. Okay. So both oscillator become similar. So up to this portion I am stopping here. Many case study I have to do, and each and every time now I have to calculate free energy, chemical potential, pressure, entropy. This time you have to calculate, and then numerical problem I will do the numerical problem in the second class. Okay, thank you.